Hi, welcome to my presentation on the topic promoting undergraduate students' productive creative thinking around chemistry concepts using real-world context. I'm Solomon Mangai, PhD student at the University of Queensland, supported by Gwen Laurie and Kim Nichols. Now, it's clear that emphasis on preparing future-ready learners that can adapt to a rapid changing world through creative thinking is ongoing and is a critical factor in STEM education. Now, achieving this can be through creative thinking competence building amongst undergraduate students. So, and it's considered a graduate attribute for their employability. Now, this study aims to enhance conceptualization and meaningful understanding of chemistry through promotion of creative thinking using real-world and dialogic context. A design-based research approach is used, whereby cycle 1 is exploration and cycle 2 and 3 is intervention enhancement. Now, in cycle 1, few instances of creative thinking were observed, and so the result was not included in this presentation. But in cycle 2, there were instances of out-of-the-box thinking, by associations, and creative abduction. Now, this is an example of creative abduction by a student. This student draws on experience of her mother, whereby the mother uses baking soda. Now, in the prompt given to these students, elements were given, of which students will use these elements and formulate a particular compound that helps in reducing corrosion. This student reflects on the mother's experience use of baking soda and then formulate that molecule of baking soda. The example of out-of-the-box thinking and by association is where a student discourse reveals circumstance where dead zone involving oxygen uptake by organisms. And now this student reflecting on that experience, which is entirely away from the concepts of chemistry or the knowledge of chemistry which they learned, the student was able to now think of, okay, why not we build metal structures in the dead zone? Because there will be less oxygen in there, and so the metals can be able to stay there without being corroded. In conclusion, promoting productive creative thinking at the submicroscopic level, especially linked with real-world context, is difficult. Although approaches in the study prove to be promising, collaboration is particularly required for examining the credibility of creative ideas. My next stage of the study is completing my cycle 3 data collection and analysis. And that will be on the concepts of solubility equilibrium. Thank you.